Hi guys, how's everybody doing? Hope you're having a good day. This lecture 1.7 is on transformations. And just so you know, transformations, just so you know, I'm gonna do this lecture in two parts, just because I'm hoping that with smaller size files, the things will upload faster. I, again, apologize for the slowness of the internet at Cuesta. They're working with it, so hopefully we can get things loaded. But remember, I'm never going to expect you to do more or go ahead if I haven't gotten there, so don't worry about it. Okay, so 1.7 is transformations. So last time we talked about our base graphs, and those base graphs, if you remember, they all seem to have that central point at 0, 0. We had the V, we had the parabola, we had like the squiggles, the arc. But those graphs, we can move around, we can manipulate their shape a little bit. And we can do that, yeah, we can do it with our calculator, but that's not what we're gonna do. We're going to do it by learning about what numbers you put into the function and how they affect the function by transforming it step by step. Okay, so when we talk about transformations, the first transformation that we're going to talk about is a reflection. And the little definition here of a reflection might not be super clear, but once you see what we're looking at, it will make sense. So we say if f is a function, sorry, too many f's going on. If f is a function, then negative f of x will reflect the graph over the, I'm having trouble here this morning, okay, over the x-axis. So by sticking a negative out in front of your function, that's going to take your graph and it's going to flip it over the x-axis. So as an example here, let's say that g of x is negative x squared. Now the negative is out front, it's not getting squared, so the negative is sitting out front. So the way that we want to show this is we would like to show this by showing our transformations, show the original base graph and then what the transformation does. So I'm going to sketch in dotted that the x squared is our parabola. So there is regular x squared. Okay. But that's not our actual graph. That's the base graph. This negative is going to take our base graph and it's going to flip it over the x-axis. So we're going to have a parabola. Again, not perfect, but this is just sketching, don't worry about it. But we're gonna have a parabola that is faced upside down. And this one here will be negative x squared. Right? So simple reflection over the x-axis. Let's look at one more of those just to see one that's a little bit different. So the last base graph we talked about was 1 over x. And, oh wait a minute, sorry, that's not what I want. Negative 1 over x. So our last base graph that we talked about was 1 over x. But I'm asking you to graph negative 1 over x. So again, we're going to think back to the fact that 1 over x was that guy that kind of has those two little arcs. And I'm just going to sketch it in like this. So that's the original. But that negative is telling us that we need to make a reflection over the x-axis. Now, if we do that though, and we go boop, this guy's actually gonna go up there, and this guy's actually gonna come down here. So both, when we reflect, the whole graph reflects. So this guy will now be in here, and this guy will now be in there. So the red is the negative 1 over x. Okay, so the blue is just where we started with our base graph, we reflected it, and now we've got the two arcs in the other quadrants. Okay. All right, so that is the reflection. Okay. So now we can turn our graphs upside down basically, which is helpful to us. So then the next thing that we want to do is we want to start moving them around. And we're going to go kind of from easier to harder in this. So reflecting is kind of the easiest transformation. The next one would be moving vertically. So let's look at a vertical transformation. And I'm not quite sure why they do this at this point, but we just called them transformations, and now they change the name and call it a vertical translation. So transformation, translation, whatever you got, just go with it. Okay, so this one says that if f is a function again, and this one has two parts. The first one says f of x plus h. Well, you know what? Let me change this a little bit here. I'm thinking into the future, into like the next chapter. Let's do k. I apologize for that. So f of x plus k will move the graph up k units. F of x minus k, actually, you know what, let's not use those either. Let's say f of x minus k will move the graph down k units. So if you add or subtract a number on the end of the function, what that's going to do is give you this vertical translation. The graph is either going to go up or it's going to go down. And it works just the way you want it. A plus goes up, a minus goes down. So here, when we're asked to graph something, let's say that we had g of x equals the square root of x plus 6. I don't know why I went so big with 6, but oh well, doesn't matter. Okay, so you see how that here is your base function, and then the plus 6 comes on the outside. It's not in there, it's on the outside. So using this idea, we look at this and we say, we're going up 6 units. So again, the first idea though is, what does the square root of x look like? So you have to think about that. You go, oh yeah, that's the guy that looks like this. Okay, so we just kind of sketch it in to show that we know what our base graph was, but now we say, no, we're gonna move that guy around. We're gonna go up 6 units. So 1, 2, 3, 4, 5, 6, and it does not need to be precise. And we're just basically sketching this same thing in, but up here, something like that. Okay. So on these graphs, really, there's no need to be precise, okay? I should not see a bunch of points plotted or anything like that. It really is more of a, hey, just kind of, what's the base graph look like and where is it? So what I see is that you went up 6 and then you drew an arc. Is it perfect? Mine certainly is not perfect. Yours is probably better than mine. Okay, but that's what we're going for there. So another one on this guy. So let's say that we had h of x is equal, I'm trying to think of one we haven't done yet, to x cubed minus 2. Okay, x cubed minus 2. So the minus 2 again is hanging out on the end. On the end, it's not inside, it's just hanging out, minus 2. And that tells us in this case that we're going to go down 2. So we start with our base graph, and remember x cubed is kind of that squiggle. I call it a squiggle. It probably has a proper name, and so I'm just sketching it in. It's the guy that looks kind of like a snake. So there's our snake. But we need to take it and move the whole thing down 2. Now the only point I'm actually moving down to is that central point. So basically I'm taking this whole graph and just shifting it down. So it's gonna still look like a snake, but it's a snake here rather than up there. All right, so when you do this in your homework, this is how I would like to see it. I'd like to see that base graph and then the transformation. So, and again, I'm not interested in what your calculator can do. I know we can graph this on our calculator. Right now I'm interested in that you know what this does. You know what that does. If I put a negative on it, do you know what that does? Okay, so let me give you one more here and then we'll move on. So what if I asked you to graph f of x, oh I changed to the black pen, well, equals negative absolute value of x plus 3. So now I'm bumping it up on the difficulty scale by giving us 2 transformations. So the negative is our reflection and the plus 3 is our vertical translation. Now, when we have multiple transformations going on, we are going to do this in multiple parts, but we want to be very careful. We're always going to start closest to the x. So the first transformation we're going to do is this guy. Okay, so that guy happens first, then we'll do the vertical. And the vertical is always going to be the last one. Okay, so we start closest to x. So multiplication is closer than addition. Okay, before we even get there, we need to make sure that we know what our base graph is that we're drawing, and that's going to be our absolute value of x, right? So we know that we're going to have a graph that looks something like this. But we're going to start moving it around and doing stuff with it. So the first thing that we're going to do is the negative. And the negative tells me just to go boop and flip it over. So in a different color pen, this is your chance to be artistic. Okay? I'm going to flip that guy down. Okay, it doesn't look great, but just go with it. But that's not the guy we want, is it? So that's only the first part. The next thing we need to do is to move that whole red graph up 3. So it still has that same point 0, 0. We're gonna move up 3. And now I'm gonna draw right on top of this. I'm gonna say there's our new point, and I'm drawing an upside down V right over the top of it. And then I'll give this guy a little label so everybody knows that that's the one that my finished answer. Okay, but here, this is like showing your work. So you've shown me the base graph, you've shown me the first translation, you showed me the answer. Okay, so that's what I'm looking for here, is not the graph itself, it's the understanding of what the transformations do. Okay, so like I said, we're gonna do this in 2 parts. So we did the first 2 transformations. Now we'll stop here and we'll come back and do the next 2 transformations. All right, so hopefully that will load quicker.